So we're going to talk today about the process by which we can take stuff like coal, which is a fossil fuel, and we can go through this whole process with this thing, and electricity comes out down the other end. So, Carl, tell me, coal is one of the fossil fuels. What's another type of fossil fuel?
Oil.
And Jack, what was another one?
Gas.
Gas, brilliant. So fossil fuels are anything that was a living thing that's died and it's gone on the ground that's turned into something that's a fuel. And we've got to dig those up, okay? Dave, what's the problem with fossil fuels?
Not renewable.
They're not, brilliant word, Dave, they are not renewable. So this coal supply is eventually going to run out when we've dug up all the coal. There's no new coal being made. But what happens is, we do dig it up, it comes on the lorries or the trains to the power station. This is what this thing here is. It's just one big power station. It's going to come down this little conveyor belt. Do you want to do the noise, Faisal, or not?
Yeah, man.
All right. Yeah, all right. Comes down here to this little bit here where you've got some grinders. You've got a mill here. So what this basically does down here is it grinds up all the coal down here into really fine coal powder, right? And when you've got this really fine coal powder being made, what it does then, it gets blown like this. It gets blown down through here into this big boiler down the end. Once it gets into the boiler, what's going to happen? Oh, I started jiggling it about. Hang on, where's my pointy thing gone? There. Once the powder gets into this boiler here, this furnace, you're going to burn it. Now, the reason they've ground it up is because it burns a lot quicker then. If you've got a big lump of coal, like if you had a coal fire, it would take a long time for that coal to burn. Grinding it up means it burns really quickly, which means this can get really hot in there. So we've got a massive fire going on in this furnace here. And then what's going to happen is that fire is going to be used to boil up the water going through this pipe here. So look, coming up through here, we've got water in this thing over here. You can't see it's blue. It's going to come up this pipe into these really thin pipes that go through the furnace, right? Now, what's going to happen then, Darren, what's going to happen to water when you get it really hot? What does it turn into?
Gas.
Yeah, but what do we call water gas? It's going to evaporate and turn into...
CO2.
No, not CO2, exactly, carbon dioxide. What do we call water when it turns into...
H2O.
H2O, it's not a trick question, it's just steam. You're being too clever and trying to think of the chemical name for it and stuff, right? So what's going to happen is all this water here is going to turn into steam and start coming along this steam pipe here. Okay, so we turned it into steam there, comes up here, goes along there, comes down the pipe here, and then it blows out really high pressure, really fast, hot steam. Kia, she comes up on the thing, that crackling. Really crackly. Stop with the coins, man, it's crackly.
Yeah, man.
Yeah, right? The steam's going to come out onto this thing here, and this is one of the important bits you need to remember. It's called a turbine at this end. Now, when the steam blows on the turbine, it's basically like a big windmill, like a fan. It spins it around really, 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 really fast. So this starts to spin really fast just because the steam's blowing on it. Because the steam's coming out into here, it starts to cool down, turns back to water, drips back into here, look, and then that water can just go round and go be used again. So the water's just going round all this way, all the way round and coming back again, basically. This thing now is spinning round really, really, really fast, and we join that up over here to this thing called a generator. And when the generator spins, the generator is what turns movement energy. What's the proper word for movement energy? Kinetic energy. Oh, did you put your hand up then? Oh, it doesn't come out on the thing. There's talking one. You've got to shout it. What are you doing with your thing there?
So it's recording.
Stop it, man. It's recorded. That fiddling will come out. Come out on YouTube, right? This kinetic energy, yeah, that's fine. Yeah. The kinetic energy that we get here gets turned into electrical energy by the generator. Then it just comes down the wires to your house. So that's the process, basically. We get fossil fuels over here, the coal. We grind it up into a powder. We blow it into the furnace, and it gets really, really hot. We use the heat there to boil the water, to turn it into steam. The steam comes along here, spins the turbine. The turbine turns the generator. That makes electricity. So we're going from what sort of energy is there locked up in the coal? And to start with, what form of energy that we talked about the other day do you reckon it would be?
Electric.
No, it's not. If it's electrical, we didn't have to do this whole process. We can just get electric out. What sort of thing was coal made out of?
Sand.
No, not sand. But if it was made out of sand, what's everything made from?
Soil.
Living organisms.
No, not everything. Not this, as in this case. Made from atoms, and atoms are what makes up chemicals. So basically, what did you say? Jesus. No, that's the wrong class for that. Right, so to start with, we have got over here chemical energy, right? I'm going to burn that chemical energy. What sort of energy am I going to get when I burn it?
Heat.
heat energy, because it's fire coming out, we're going to get heat energy coming out there. The heat energy then boils the water turns to steam and starts moving down the pipe. So what sort of energy is that if it's moving down the pipe? Kinetic energy. Nick, don't put your hand up, you can't see your hand on the thing, just shout it out. Right, we're going to get kinetic energy coming out there, and I can't fit it on, so I'm going to go back over here again. That makes the turbine spin round, which is just more kinetic energy, okay? The kinetic energy turns the generator, which then turns that kinetic energy into the electrical energy that I can't fit on here, right, that we need. That's the whole process. What's the big problem with this then? It's nice, we put coal in, get electricity out. What is the big problem with it? When we burn it, well, go on.
It takes time.
Takes a lot of time to do. Yeah, this would take a really long time to start up and get going in the morning. What is getting produced that's coming here and coming out the top over here that someone said just now?
CO2.
Go on, Nick. Go on, your hands up. What? Yeah, gas, but what gas is it?
CO2.
And CO2 is a type of, what type of gas? What do we call it? Carbon dioxide, but it goes up in the world, greenhouse gas. Good, it's a greenhouse gas, and that causes global warming that we talked about the other day. So that's a big problem. Also, every single stage of this thing, I'm just going to change the colour. This is not the blue pen, Nick, but it's red's most relevant in this case, okay? When I do this pipe here is going to get hot as the steam goes through. Is the fact that the pipe's hot making the thing spin round any quicker? No, it's not. So that's a waste of energy. This thing, as it spins, it rubs on its little axis. Is the fact that that's rubbing and making the little axle hot, making it go any quicker? No, it's a waste of energy again. Is the fact that this whole thing's probably really noisy and you're getting loads of sound energy making electricity? No, so there's loads of wasted electricity in it. There's loads of wasted energy all the way through this process. But we've got to do it because that's the only way we can produce the amount of electricity we need at the moment. Grind up the coal, burn the coal, use the heat to boil the steam, use the steam to spin the turbine, use the turbine to turn the generator. That's what makes electricity, and that's what makes us happy at home down the end, a little smiley face.
Yeah, man.